Good afternoon. Today's lecture is on overview of spatial data quality, also known as SDQ in short. In this lecture, we will study about the basic concepts of SDQ and what are the parameters to access quality of any spatial data. So overall learning objective of this lecture is to understand data quality elements and fitness for use, how to judge the data is fit for some particular kind of application. Learning object outcome of this lecture is that it is expected that at the end of the lecture you should be able to explain elements of data quality and its importance. So as you are already aware, GIS database is the model of real world, or it is the computer representation of real world phenomena. For example, uh, representation of land cover classes, representation of land use. So these are the real world phenomena, representation of elevation, representation of temperature. So in a computer, in GIS database, we use point, line, polygon, or the raster data model to store GIS data. And nowadays, since availability of GIS data from different platforms is too much. So what I mean by too much, today satellite imagery is very easily accessible to any person. He can create the data and put the data in open source domain or share the data. So and the person who is creating the data, he may not be expert in data creation, or he may not be expert in image interpretation. He just have created the data. So there are many, or there is a large possibility of having error in the data. So if you have to use the data, you should be knowing that it is good to use, means the data is fit to use for your purpose, or some modification, some updation is required. For example, very easily you can download the data from OpenStreetMap, or suppose you have to download the data, download the road database for your city, for your country. What you do first, save file of country boundary, save file of India boundary, save file of some state boundary. This kind of search we do. Then next table we find out road database of some particular country, and we get something in return from the Google and download, and we start using it. But before using that data, you should be knowing it is fit to use, it is error free or not. So the data need to be evaluated first based on certain parameters. So it's like if you are going to market and purchasing anything, any good, any object, you do certain kind of evaluation. It may be based on look of that particular object. It may be based on the price. It may be combination of both look price, availability, size. So based on these things, generally evaluation of different objects is done. On the same line, in spatial domain, we are having the spatial database. There are certain parameters based on which data is evaluated to know that the data is fit to use for me. So for example, uh, here we will see just one simple example about possible error in databases, GIS data. Uh, the screenshot you are able to see here, I just opened Google Map and search for Volkswagen Dehradun. So it should give me Volkswagen centers, workshop, or Volkswagen showroom in Dehradun. Then based on this, I may start navigation or do whatever I want with this location. So I just have searched this Volkswagen Dehradun. It has given me this location. The red bubble is the location which you get in return after searching. And here you can see this uh, white color patch or bright color patch over this yellow color road. So according to this search, this white color patch on the yellow color road is the Volkswagen Dehradun showroom. So here you can see with this that road feature and this Volkswagen location, they are overlapping, means these two polygons, white color patch and this white color patch is overlapping with the road, that you can see clearly. So which means there is some inconsistency, means this data is not logically consistent, because a building, an area cannot overlap a road, otherwise road will be blocked. It means with this appearance, it with this image, it appears that the building, the area of Volkswagen is built over the road. But for further investigation, let's see how it looks in satellite imagery. So here is the satellite imagery. When I open satellite imagery of uh, the same location, what I saw is this. The bubble is here, and here there is no building. There is nothing, which clearly says that, which clearly means that the location of the POI, point of interest, I have searched, this is wrongly marked in the database. Actual location of the Volkswagen Dehradun showroom is this, but the search result is giving me location here, which is wrong. And this is wrong based on two things. One, there is error in the position. Also, if you see vector database, the road feature and this POI, these two features are overlapping, which means the data is logically inconsistent. So this is one example. Why do we need data quality? So if uh, suppose you have got this kind of data which is having these many meters of error, and you have to use this data for fine scale planning like cadastral kind of mapping. So this much error in the data, you will not be able to use for cadastral mapping, because in case of cadastral mapping the size of land, size of plots is smaller, and in that case you need highly accurate data, not this. This data you can use for a small scale applications where precise location is doesn't matter too much. So this data is fit for small scale application but not for large scale. What I mean by this data, the data which is having uh, inaccuracy. Now let's see another example where data quality matters. Suppose uh, you are given with a land parcel of 200 square meter area, and you need to measure the area using GPS and using satellite imagery. This 200 square meter is the actual area which is measured which is calculated based on ground measurements like or terrestrial measurement using meter scale. But what will you get if you are performing measurement using GPS? How can we do measurement? So in this case, suppose the shape of land parcel is rectangular. So let's say length is 20 meters and width is 10 meters. So area will become 200 square meters. But if you have to perform the measurement using GPS, what will you do? Simply collect coordinates of opposite points, or collect coordinates of all the locations, collect coordinates of all the 4 locations, and once you have the coordinates, for example x1 comma y1, and these x1 comma y1, these are longitude and latitude. For this, from GPS measurement you will get x2 comma y2, longitude and latitude of this location, then again x3 comma y3, again x4 comma y4. So these 4 coordinates you will get. Now with these 4 coordinates, length of each side can be calculated using a distance formula: square root of x2 minus x1 square plus y2 minus y1 square and square root of whole. So this way you will be able to measure length as well as width of the land parcel, and if you multiply them, you will get the area. But here you will get exact 200 or less or more, that depends on the accuracy of these coordinates. So if there is error in the GPS coordinates, you will get an area which will differ from exact number. So you may get like 190, you may get 190 square meter after calculation, or you may get 192, 195, 199, 200, 201. Any number you can get, and that depends on the kind of accuracy your measurement is having. If you are using a mobile device which is not so accurate, which will have inaccuracy of 10 meters, or accuracy of 10 meters or 5 meters, like that, accordingly you will see error in the measurement. If you are having GPS which is giving highly accurate coordinates, you will be able to do precise measurement of the area. So here it depends which kind of GPS readings you will accept, and again it depends at what is the purpose of application. Means if the size of land which is being measured is very large, so in that case, suppose length is 1 kilometers and width is 2 kilometers, this kind of measurement you have to do. And if in that case there is an error of 2 meters, 3 meters in the measurement, that doesn't matter. Percentage wise, that will be very less. But if you have to do a large scale mapping where a parcel of land is like 20 meters or 40 meters, 50 meters, in that case, 5-10 meters of error is too much. So you need to, so you have to use GPS on GPS readings or not, or which kind of GPS you have to use for which kind of mapping, that depends on the kind of mapping. Based on the kind of mapping, you will come to know that kind of accuracy needed. So the role of data quality is increases. The role of data quality increases once you go for large scale applications. For small scale applications, even less accurate data will work. Similarly, now suppose instead of using GPS, suppose you have to use the satellite image to find out area of the land parcel. So what do we do with satellite image? You take the image and mark the boundary of land parcel. But the accuracy, in that case, accuracy of digitization matters. If your digitization is highly accurate, then you can accurately measure the area of small parcels. If digitization accuracy is lesser accurate, then you cannot use that GIS data for cadastral mapping. So the accuracy of digitization depends on what? It depends on the image interpretation capability and the skills of the person who is doing digitization. So let's assume in this case that the person who is digitizing is very skilled person. So which means we can ignore manual errors. But what about the limitations? Suppose for land, this example, 200 square meter land parcel measurement. Suppose you are having a satellite imagery of 10 meters. So in that case, if you will try to mark the boundary, you will not be able to mark the boundary properly. Now, suppose you are having a satellite imagery which is having spatial resolution of 5 meters. So earlier I have made, we have assumed that our land parcel is something like this: 20 meters length, 10 meters width. If our satellite imagery is of 5-meter resolution, then there may be the case like 1 pixel, 2 pixel, 3 pixel. So this can be 5 meter. If our satellite imagery is like maybe like this, so your pixel, complete 1 pixel will contain this boundary. Now this boundary of the parcel is passing through center of the pixel or edge of the pixel or from where it is passing. So someone can mark on the edge of the pixel or center or wherever within that pixel it can be marked, which means there will be a possibility of deviation in the position of the boundary, possibility of 1 pixel deviation in the position of boundary. So accordingly, you will get error in the area measurement. So again, if you here quality comes into picture, data quality comes into picture. If we have to do assessment of the data, that the data which is having boundary of the land parcel, it is useful for you or not. How will you do? First you ask at what which kind of satellite imagery was used to digitize this data. So if answer is like 5 meters spatial resolution was used and size of land parcel is 10 meters, then obviously you can reject that data, that this data is not useful for me because this will have an error of 5 meters, whereas my land parcel boundary is 10 meters wide. So in case of 10-meter wide boundary, 5-meter error means 50% error possibility is there. So which means your area measurement may be 300 square meters with that boundary or 150 square meters. So what kind of data you need? You need a data which is having accuracy. You need GIS data created from not GIS, you need a vector data digitized from a satellite imagery of centimeter resolution. Then you can trust the data more. There are data products of 50 centimeter resolution. So if you are using that data, which means 50 centimeter error in position of the boundary, 50 centimeter of 10 meters is very less. So that kind of digitized data you can use. So such kind of what are other parameters based on which the judgment can be done. So here we have seen one parameter can be in this case satellite imagery, position accuracy of GPS, that is another parameter. Here in this case position of any point of interest, so positional accuracy is one parameter. So in case of the map example, different set of parameters were needed. One was position was not accurate and the Volkswagen boundary was overlapping with the road, so consistency was not there. So different parameters needed there. And here in case of land parcel, accuracy of GPS and satellite imagery resolution. So which means different kind of data needs different assessment parameters. So in today's lecture, we will see what are different assessment parameters available based on which accuracy assessment can be done. Now we will come to formal definitions of data quality. Till now we have seen the example where data quality, where some error was there. So we can, based on the error, we can say data is of poor quality. So quality generally refers to good or useful thing. So this is general term. Quality is general term which refers to good or useful thing. It can be quality of mobile phone, quality of study table, quality of laptop, quality of building, anything. So this term indicates the superiority of the material. It can be manufacturing superiority, it can be superiority of the material used for making of that particular good. In case of laptop, in case of mobile phones, quality of processor, display quality. Many things are there. So generally, quality is applied uh, based on the context. Context means if you have to judge the quality of study table, there will be different parameters. If you have to judge the quality of workstation, there will be different parameters. When it comes to quality of the data, it becomes very difficult to define and it becomes difficult to judge. Why it becomes difficult? In case of physical products, you can see the manufacturing, you can touch, you can see the visual appeal, you can see the material used for the casting of that product. But in case of data, things are in virtual mode. Data is in, you cannot touch the data, you can visualize the data, but visualization is not as similar as visualization of any physical object. So completely different set of parameters are needed to access the quality of digital data. And any data is fit to use for you or not, that can be accessed based on these three steps given by Vanwood, and this he has given these three steps. If you just simply ask the question, does the data set contain the information required for the intended application? So if you are getting answer for this question yes, then you can go for the next question. What are the legal and financial constraints to access or use of the data? You can access the legal and financial constraints to use that data. If things are okay, legal constraints are okay, financially it is okay, then are the data of sufficient quality for your application, then this quality assessment can be done based on again 8-9 parameters. So if you are having a point of interest data, road database, the land cover information, this kind of vector data is available, and your application needs these topographical information like land cover, road, point of interest, school information. If this a data set which is having this kind of information, then you can say that yes, this data is useful for me. Then asks next question, legal and financial constraint. Legal means there may be some data available, but not for the public use, not for the public distribution. So in that case, you will not be able to get that data. Like in each country, survey organization, they have a large amount of survey related data, but whole data is not meant for the public. You may think that if you get the data, you can do very good kind of research and you may end up very good results, but due to legal restriction, you will not get the data. So the data becomes unfit for your use. There may be chances that legally it is okay, and financial constraints may be there. There may be money required to purchase the data, but money may not be available, or that much money may not be available. We'll just look at the satellite imagery. There are satellite imagery of one scene of 1,000, 2,000, 4,000, and there are imageries with, for which a price per scene is like 0.1 million, 0.2 million, 0.5 million. So this much difference in price is there for different kind of satellite imagery. So if there is financial constraint, then again that data becomes unfit for your purpose because you will not get that data. So obviously you cannot use that. If all these things are okay, legally it is okay, financial constraints are also not there, then you can do uh, quality assessment. And by the way, why data quality is needed? Uh, One is because of availability, change, and use of spatial data. If you talk about 1950s, 40s, 60s, in that time, the survey analysis, these kind of things used to be done by uh, authenticated people who were properly trained and they were doing research and working in research and application in that particular area only. For example, survey organizations. So any data created by those organizations passes through different quality checks, different accuracy assessment, and then the final result comes in the form of database. So that time, it the data created was going through all the quality checks and balances. So that was a good quality, accurate data. But nowadays, what is happening? Satellite imagery is very easily available. Many satellite imageries are freely available. Platforms to create the data, like I mean GIS software, they are also available in open source domain. Anyone can download the satellite imagery and do the digitization. Then after doing digitization, without any checks for accuracy assessment, the data can be shared. There are open platforms to share the data or simply send emails, send the data in hard drive. There are many ways to share the data among peers at least. So you can see here the data is not passing through the quality checks. So there is a large possibility of error. Even if there is not error, the data created maybe for may have been created for different purpose. For land cover mapping at 1 raised to 50,000 scale, it may have been created. But if the data had to be used, if the data had to be used by someone who needs a data resolution of data scale of 1 raised to 5,000, then the 50,000 scale data cannot be used. So that is also one of the quality issues. In previous times, this much availability of data was not there. Data used to be created for special purpose and application. So the scale problem and those accuracy checks problem, those things were not there, but today they are there. Another problem is growing group of users less aware of spatial data quality. Uh, there are many people are easily data can be created without having any awareness of data quality. That there is a concept of crowdsourcing, participatory GIS, where people participate in creating GIS data set without having knowledge of GIS. It's like simply sending the point of interest location using the mobile app. So there can be expert, even if you don't say expert, there can be one informed person a person who knows about GIS, who knows about accuracy, if he is sending any data from GPS, he will simply wait for some time to uh, so that observation time increases, and if observation time increases, random errors can be minimized in the observation. So, but if some new person who is unaware of the concept of accuracy, observation time, random errors, so he will simply go to a location and click the GPS location in few seconds. So there will be accuracy problem in that case. That is one example where people participate in data collection, but they are not aware about SDQ. Another problem is GIS softwares can process any data irrespective of its quality. Any data means any GIS data irrespective of quality. Doesn't matter there is error in position, doesn't matter there is error in coordinate system or whatever. They can simply process. You just open the software, you input data, it will give some result. Later on, if you do the quality assessment, then you will come to know that since input data was not accurate, hence you are getting errors in output. Another problem is hardly there are any tools for handling spatial data quality. There you can find the tools for uh, positional accuracy assessment, attribute accuracy assessment, but there are many other parameters for which hardly there are any tools. And distance between those who use spatial data and those who are best informed about spatial data quality. Many times, I'm not saying all the times, people who are using the data, they are less aware about the spatial data quality. So that is why the spatial data concept is needed. Before going to exact concept of SDQ, exact parameters of SDQ, first let's see how error can be created in the data creation process, or uncertainty can be created in the data creation process. So there can be three stages of error insertion. One is the stage where conception is done. Conception regarding representation of data is done. So in that stage, error can be included. It can be error in the form of location of the boundary, error in the representation, the object on the ground should be represented in the form of point or line or polygon. In that form also error can be there, because if a polygon-like object is represented in the form of point, then there will be positional error, and positional error comes with attribute error also. So if there is positional error, automatically it will attract the attribute error. Then comes error in the form of uh, measurement. Uh, One example, as I told, GPS measurement and representation. If you are using coarse resolution satellite imagery and you want to perform measurements and you want to represent any feature, that will have errors. Then comes analysis. In analysis stage, error propagates from previous stage to next stage. Like if you have created the data and you do simple overlay analysis or spatial analysis similar to which you have seen, and if there is error in your source data, you will get error in output data also. The conceptual stage is subcategorized under vagueness and ambiguity. Vagueness is because of poor definition. Poor definition can be in the form like suppose you are digitizing land cover classes, and if in digitization you have to mark the boundary of each feature, and while marking the boundary uh, you are not sure that where one feature is stopping, what feature class is stopping, and where another begins. For example, boundary between grassland and forest. It becomes uh, difficult to identify exact boundary because of following reasons. One, mixed pixel. At the boundary, there may be a pixel like this. Suppose this is a boundary, and obviously pixel will have some size, and this side suppose there is a grassland, and this side suppose there is a forest. So the boundary pixel will have signatures of grassland as well as forest both. So exactly you will not be able to identify that where should be boundary. It should be either here or in between. So that way the confusion comes because of mixed pixel. And another reason for this confusion can be like the appearance, grassland and forest in RGB mode, both will appear green. In FCC, both will appear red. Obviously, there will be difference in contrast, but it will not be so different to mark the crisp boundary. Another reason can be the shadow, since forest height will be there, and because of the forest height, there will be shadow in the region, and because of the shadow, signature of feature will be totally different. So again, because of these things, you will not be able to mark the boundary correctly. So if it is that's the poor definition, which means the boundary is not defined properly. In case of ambiguity, there is a confusion about representation of geographic phenomena, how it should be represented, and what kind of attributes should be assigned to it. Means it should be represented in the form of point, line, or polygon, and point-like object is represented in polygon. Then there will be positional errors. So these kind of things are there. In case of measurement and representation, resolution of the image matters a lot, and it depends on the scale of mapping. If you are doing small scale mapping, then resolution needed will be different. If you are doing large scale mapping, then resolution needed, spatial resolution needed for satellite imagery will be totally different. Then density of observations. In case of GPS readings, density of observations matters. Earlier I told someone can send the take the GPS data within a second, and someone may take some 5 minutes, 4 minutes, 10 minutes. So that what is the advantage of taking data, taking 10 minutes time to mark the data, collect the data. If since we know any observation performed by any instrument, anyone have bias, a systematic bias which is constant throughout each observation, and that have some random errors. Random errors can be because of any reason, because of environment, because of handling, because of number conversion, whatever reason can be there. But if and random errors are positive or negative both, which means you can have like if you have to measure any location, you can go in positive as well as negative direction for each measurement. But when you will do mean, if you find out mean of the data, observed data, you will see that some of the random errors becomes zero when number of observations are large. So that is why if observation period is more, which means if density of observation is more, which means uh, random errors are less in your observation. And fuzzy natural boundaries, we have seen earlier also what uh, can it lead to. Then digitization error is manual error, image interpretation error, mouse click error. So because of those errors can be there. Then instrument limitations are also there. For example, collecting reading from GPS. You can use a GPS to get the location of any POI, point of interest, and you can collect the reading using your normal mobile devices. So reading from mobile devices, they mobile device is having their its own limitation. It is not very much accurate, or you can say mobile device. Simple mobile device. I mean mobile phones. GPS reading from mobile phones is not as accurate as GPS device or the independent GPS device. That is because of limitations of the different measuring instruments. Then in analysis stage, the error in data can be because of approximation in the model. It can be numerical error in the computing process, because sometimes when you have to do computing faster, you need to uh, decrease the size of the data. Means precision you need to decrease. If you are storing the data in float 32, float 64, then the size will be larger. And if you are storing float 16, the size of storage will be lesser, but accuracy decreases. So you have to think that what kind of data type need to be used. Then error propagation from, if your source data is having error, then your final process data will also have some error. So now if there are so many errors, how will you track them? How will you find them out? Uh, these are the data quality parameters: lineage, positional accuracy, attribute accuracy, logical consistency, completeness, temporal quality, uh, usage, purpose, constraints, uh, quality, metadata quality basically, uh, resolution of the data. It can be scale, can be pixel size. Now we will see them in detail. When it is accuracy, bias, and precision. Bias means it is a mean error, also known as systematic difference between observed value and true value, which means uh, this much error will always be there in any measurement, any single measurement. And in addition to this, there will be random errors. So or you can say bias is the constant error in the observed value. Then there is a precision. Precision is a measure that how closely the data points are spread for repeated observations. So there can be situations where there is bias in the measurement, but data is precise. Then accuracy of the data. Accuracy means spread of the data around true value. There is the difference between precision and accuracy is in case of precision, spread of the data is around average value of the observed data. That is basically standard deviation. Standard deviation of the data is measure for the precision. Accuracy is spread of the data around the true value. Now let's see in detail. Not detail, let's see one pictorial representation. Here in this case, suppose the position of this crosshair, the position of this crosshair was to be measured using GPS, and with these six observations of GPS are like this. What can you see from this? The spread of the data around the mean of observation is lesser, which means standard deviation of this observed points is lesser, which means this is more precise. And spread of the data around true value is also lesser, which means this is accurate also. And deviation between mean value and true value. Mean value of this data will be somewhere here, and true value is the crosshair. So deviation distance between mean value and true value is also lesser, which means this data is unbiased, accurate, and precise. Here, what happens? Uh, all the values are closely spread over the observed mean value, which means this data is accurate. Sorry, which means this data is precise. Precise means standard deviation is lesser. Means values are closely spread around measured mean, which means this is precise. But is it biased or unbiased? How do we test biasness? The deviation in mean value and true value. Mean value will be somewhere here and true value is here. So which means there is biasness in this data. So this data is biased, and this is inaccurate also, because true value is here and measured values are here, which means the measured values are not closely spread along true value like this, like the previous one. So this becomes precise, biased, and inaccurate. Here, uh, data is spread around true value, so but the standard deviation is larger, which means this is less precise, and there may be deviation in this case from true value to measured observed mean value. So slight biasness, you can say. Then this data is spread around true value also, but not properly. So everything is slightly here, slightly precise, slightly biased, and slightly accurate. Here, the data is not closely spread along the observed value, which means standard deviation is larger here, which means this data is not precise. And uh, deviation, the, the spread around the true value is also larger, which means this data is less accurate or inaccurate. But if you find out average value of position, that will be the center point, somewhere in center point. So this is unbiased but less precise and lesser accurate. Now to find out the biasness or accuracy of the data, you need to have some truth. Here, how are we finding out accuracy and biasness of the data? Simply comparing with comparing observed value with true value. So, which means you need a true value to access the accuracy, bias, and precision. Precision can be accessed on its own, but for accuracy and biasness, you need a reference data. But at the same time, uh, when we are using some reference data, there should be enough reason to believe that the data being used for reference is of high quality. If data is of high quality, then only it should be used as reference. Otherwise, it will be like comparing inaccurate data with uh, inaccurate reference. So at the end, whatever conclusion you will draw, that will be wrong. Positional accuracy is another parameter for quality assessment. In case of closeness, in case of positional accuracy, uh, closeness of the measured location of measured point to the truth value is found out, or if it is for positional accuracy assessment of line, then the the closeness of line to the true value is found out. So if uh, we are having good quality reference data, then only we can find out the accuracy assessment. It can be positional accuracy or attribute accuracy. But in case of attribute accuracy or positional accuracy, if this or any kind of accuracy, if reference data is not available, then there may be a need of GPS based survey or ground data to access the accuracy. Attribute accuracy refers to the closeness of attribute values to the true values, which means example can be like whatever land cover class is assigned to any polygon, is that the correct land cover class or not. Whichever polygon is assigned as building, whichever polygon is assigned as park, is that the correct name or not. So that is the meaning of attribute accuracy. If high quality data is not available, then field survey is needed. But at the same time, we have to keep in the mind, since you are doing field survey for accuracy assessment, then your field survey should be of high standard. It should not be that casually points are collected from the ground. The points collected from the ground in casual manner, they will have their own inaccuracy. So at the end, whatever conclusion you will draw, that will be wrong. Uh, there are four categories of data: nominal, ordinal, interval, and ratio kind of data. So in case of categorical data, nominal or ordinal, both are categorical data. In that case, name are assigned to the uh, class. It can be land cover class, it can be name of the road, type of the road, then it can be the names can be assigned for like elevation zones, low elevation zone, medium elevation zone, high uh, elevation zone. So that kind of ordinal data can also be there. So in case of nominal and ordinal, the accuracy assessment is done using creating confusion matrix. In case of numerical data, the ratio and interval data, where numbers are assigned, floating points numbers are assigned instead of names. In that case, the percentage accuracy is calculated. For example, concentration of pollutants in the soil, height of trees in the forest, temperature in the region, rainfall in the region. So these kind of things, they are represented in the form of numbers instead of names. So the process of finding out accuracy is different for uh, categorical data and numerical data. Then there is temporal accuracy. Temporal accuracy of spatial data refers to a difference in the value of the object location at different times, which directly means that your data is updated with respect to time or not. For example, you have created a data in 2020, and today there may have been some different development in the form of road development. There may have come new park, new buildings may have come, or land cover scenario may have changed. Instead of forest, there may be agriculture now, or instead of agriculture, there may be colony now, residential area now. So this way, data is updated with respect to time or not. You have to check that it is updated. Otherwise, you will end up with the wrong conclusion. Like over a period of time, uh, boundaries of the land parcel remain fixed, but ownership of the parcel may change. So if you are working for cadastral level mapping, in that case, the temporal accuracy becomes more important because regularly or very frequently, at least ownership of the land changes. Completeness of the data is another parameter. Completeness refers to presence of the features, attributes in the database. So this is evaluated based on the comparison of data with respect to reference data with respect to the requirement. Like if you are if your purpose needs a topographical map, complete topographic map, which means the data sets would have all kind of features. Sometimes you may need only land cover representation, land cover classes. So the meaning of comparison changes. For a user who needs topographical data, meaning of completeness is different for them. And for a user who needs only LULC data, the meaning of completeness is different. Logical consistency is very important. Logical consistency is related to the logical rules of data structure. It can be conceptual consistency, absence of any contradictions. If you remember in the beginning of the class, I have shown one image where road was there and one white color patch was marked like this over the road. So that kind of thing is logically inconsistent data because the building cannot be like this, which cannot cover a road like this. If it is covering, then this kind of coverage of the road is possible only if there is elevated surface over the road, not general. Then domain consistency can be there, like allowed attribute values. Suppose you are representing data of age groups where you are entering age information in one attribute column. So if you are representing age, which means the range of value can be more than zero. It cannot be negative. So if there is some negative value in age column, which means the data becomes logically inconsistent. Then format consistency, it should not be mix up of text and numerical data. Topologically, the data should follow the topological rules. Lineage describes the history of the data or history of the data creation, how data is created from its source and which kind of processing steps are used. This will give you the complete knowledge of data creation, complete information of the data creation. And with this, you will come to know that source of data creation means source satellite imagery, which satellite imagery was used, and with this satellite imagery you will come to know that spatial resolution of the satellite imagery. So is that your data useful for you or not? There may be some data created with respect to modis data which is having more 500-meter resolution, even more in some bands, and the data may be useful for some other purpose. But if you have to do terrestrial level mapping, in that case, you need worldview kind of data. If lineage is not provided, or at least data source and processing steps they are not provided, then it is not possible to see the fitness for use, because you will not be able to conclude that data is useful or not. One more element left, that is meta quality. Meta quality is related to quality of metadata information. So this means meta quality provides information on the quality of uh, data description. And this metadata quality, it's like data quality can be uh, given in any format, or the data quality parameters should follow some standards like ISO standard, USA SDTS standard, so that anyone can understand meaning of the different parameters easily if things are standardized. It should not be like the quality data quality is written on simple plain text. Bottom line is uh, these parameters should be that given in such a way that they should be uh, understandable by any person. And here you can see that in this case, positional accuracy is numerical value, attribute accuracy is numerical value, but when it comes to temporal accuracy, completeness of the data, logical consistency, lineage, these things you need to check manually. Intelligently, you need to check, because software tools are not available, and it cannot be checked so easily. Like topologically, if data is topologically inconsistent, it can be checked, but it is complete or not, it is difficult to check in automatic mode. It is temporally accurate or not, it is difficult to check in automatic mode. So it need to be checked depending on the purpose. Summary of today's lecture is: any poor quality of raw data leads to poor quality end product because of error propagation, and required quality of data depends on use of the data. You have to do cadastral mapping or the small scale mapping. For example, if you have to do studies, if you have to do research at smaller scale, you may need very high accurate data. But if you have to do navigation, road road navigation, for example, you need a highly accurate data. If the data set, road location, point of interest, they are not marked properly. Just suppose that you are using the data which is not accurate for navigation, so it will ask you to take a left turn and there will be no turn. Many of you may have faced also using while using map navigation. Not Sometimes it will ask you to take the turn, but there will be turn at least 50 to 100 meters away from the location where it is asking you to turn. Sometimes it happens, not always. So these things are because of errors in data, quality issues in the data. So this is end of my lecture. Thank you for your attention. You can post your queries. I will address in 5 minutes.